Welcome back. Today we're going to be talking about the chi-square test. So there are two versions of this. There's the one variable one and the two variable one, which you'll be looking at in this video. You can find the one variable one in another video. So the two variable one is also called the test for independence. This is an example of the two variable one. In 1912, over 800 passengers perished after the Titanic collided with an iceberg. The following table compares the survival frequencies of cabin and steerage passengers. You have the table there, and using a 5% or 0.05 level of significance, test the new hypothesis that the survival rates are independent of passengers' accommodation. Right, so in simple words, this question is really saying you have statistics there of people who lived on the cabin on the steerage on the Titanic, and then you have the number that survived and the number that didn't survive, right? So you're trying to test does it matter where you were on the Titanic in terms of your survival rate, right? So you're trying to see if these two things are dependent or they're independent, right? So before we move on, one of the key things is to be able to distinguish between the one variable one and the two variable chi-square test, right? So that's important because the kind of procedure is a bit different depending on which version of it are you doing. So there's two variable one. One tip is usually if you're given a question in a table like this, where you have categories in the columns, like here you have two categories, cabin and steerage, and then you also have categories in the rows, you have yes, no. That's a giveaway that it is a two variable one, right? Another thing is that a two variable one, sometimes you're not given the table, so you have to kind of read the question and then kind of see that there is two versions of the thing. So if you're given categories like policemen, for example, policemen and military people, so those are two categories or two jobs, and then you're also given that these people can be smokers or non-smokers, right? So that's a giveaway that it is a two variable one because you have two categories, but within those you also have two versions of it, right? You have smokers or non-smokers. In this case, we have yes, no, or survived, didn't survive, right? So that's a two variable. Whereas a one variable, you just have police and military people. Or in this case, if this was a one variable, you just have the cabin and steerage people. You wouldn't have another thing, another version of them, like those who survived and those who didn't. So it's important that at the start of the question you decide what it is. So here we decide that it is a two variable one. And then we're going to use this formula. We need some observed values. Observed values are the values that were recorded or measured in an experiment, or real values. These are values you actually seen. So these are always given in the question, right? The expected values, you have to calculate them. These are values that are not real, that you calculate, you fabricate. And then we need those two. We square that. We take a difference, we square, we divide by the expected, we sum all the contributions, right? We use that formula. So we need those things. We need the observed values, the expected values. We need those, right? If you're doing this for a college assignment or it comes up in a test, usually there are marks that goes for the new hypothesis and the alternative hypothesis. So you always have to write those first at the start of the question. These are the things you're testing, and ultimately you're going to pick one of those as the correct answer, right? So you have to write those at the start. So the new hypothesis is passenger survival rates are independent of passengers' accommodations. So you can write that in those words, or you can just say it doesn't matter where the passengers stay in terms of whether or not they survived. Any of those words, they're not specific words, but anything that you're saying, these two things are independent of each other. And the alternative one, you're saying they are dependent, or you just say H0 is false. So usually H1 is always H0 is false. So it's the opposite of H0. So you read H0, whatever it's saying, it's false. That's what H1 is saying. So you write those, there's always marks going for those two at the start of the question. So we've decided it's a two variable one. We've written our hypothesis, and then now we have to test those hypotheses, right? So we create a new table where we have the observed and expected values there. So it's as if the original table, it's expanded where we can now accommodate the fact that there is observed values, which are values that were given, and we also have expected values that we're going to calculate. So we have the table there, and we put in our observed values. So these are values that were given. We just put them in the appropriate box. So we don't know the expected values. So the expected values, I put question marks there because we don't know what they are, right? So we need to fill those in. Once we have filled those in, we are ready to use the formula on the top right there, which takes in observed and expected values. Right, so how do we find those expected values for each row and each column? We use this formula here. So expected values or expected frequencies, or FE. So FE means F expected, FO means F observed. So FE is a row total times column total divided by grand total or overall total, right? So in the one variable test, you don't really need to make a table, but in this you do, because you need to calculate these values based on rows and columns. So this formula really is referring to your table. If you don't have one, then you can't use that formula. So you need to make a table for the two variable one, and then find out what's the row total and the column total of the observed values. So for the first row of the observed values, we have 299 and 186. We add those, we get a value of 485. We do the same for the second row, 280 and 526. We add those, we get 806. And then we add those two numbers, 806 and 485. That gives us our grand total. Or I just add all the numbers that were observed. It also gives you 1291. And then you do the columns, 299, 280, add those up, 579 you get. And then you do the same for the next row, 186 plus 526, you get 712. So you now have your totals, your row total, column total, grand total. You have all of those. You're ready now to use that formula to actually find the question marks, the FEs, the expected values, which remember you need to use for the formula in the top right, the chi-square formula there. So we use the formula, the expected frequency formula, FE equals row total in the first question mark, or the one, the expected value for the cabin survivors. It's row total, which is 485, times the column total, 579, divided by 1291. We get 217.52. So we put that in there. We'll do the same thing for the stereo survivors. 485, that's the row total. Column total is 712. And then the grand total is always 1291 for this table, right? It's going to be the same total. We do the same for the cabin non-survivors. We get 361.48. We do the same for the storage non-survivors. We get 444.52. So these are our values. So these are the expected values. Again, expected values, they have decimal points. As you can see, you can't have a fraction of a person. So, but these are expected values, so that they are fabricated, but they're not real values that actually were there, right? But we can still use them with the decimal points, or you can round them, whichever, you get some answer that is similar. So after you now have the table filled in terms of you have the observed values, the expected values, you have all of those, you're ready to use the formula then, right? So you're ready to use the formula that takes in observed and expected values to get the chi-squared value. So for the first box, or the first set of observed and expected values, the 299 and the 217.52, we use the formula 299 minus 217.52, you square that, divide by 217.52. So we're just following the chi-square formula. And then, so that's the contribution for the cabin survivors. We do the contribution for the stereo survivors, 186 minus 267.48 squared divided by 267.48. We get some value. We add that to the cabin non-survivors, which is the 280 minus 361.48 squared divided by 261.48. And then we do the same for the last one. We add all of those up. So the contribution for each, 30.52, 24.82, 18.37, 14.94. We add those up, we get 88.65. So that's our x-squared value. At this stage, if you're doing this in college or for an assignment, you will have 60-70% of the marks. So you have found the x squared value, but what does that actually mean? Remember, you have to answer a question, right? You have to pick one of those hypotheses and say it is true based on the value, the x squared value that you get. So we have a value. Now we need another value to compare our value to. So if our value, the 88.65, is higher than the critical value, right, some critical value that we will find in a table, in a standard table, if our value is higher than that critical value, we reject the null hypothesis and accept the alternative one. But if our value is lower than the critical value, we accept the null hypothesis. Right, so here's the question again. Using 5% level of significance, test the null hypothesis that the survival rates are independent of the passenger's accommodation, cabin, or steerage. So what we extract from this is the 5% level of significance. So we go to the tables. These are tables you can be found online or in standard log tables. They are standard tables, right? The values in those tables will be the same. So we're using 5% level of significance. So here we go on the column that is 0.05 or 5%. So we know that our critical value is somewhere in that column. But we need to find out the row then, what the value is. So we use degrees of freedom to find the row. So how do you calculate the degrees of freedom? Again, this is a bit different from the one variable one, the way you calculate the degrees of freedom. So in this case, degrees of freedom are given by C minus 1 times R minus 1. So C is column, R is row. So this is referring to the original table given with the observed values only, without the expected. So with the observed values only, which is the table we see on the top there, the original table in the question, it has 2 columns, which is the cabin and steerage, 2 categories, and then it has 2 rows, yes, no. So we're going to have 2 minus 1 times 2 minus 1, which gives us 1. Right. So again, be careful when you're doing this formula, when you're calculating the degrees of freedom. The rows are not the rows of your table, the one you make up, the one with the expected and observed. It's the rows of the original data, which is just the observed values, right? So it will be 2 rows. It won't be 4 rows, right? So you get 1 degree of freedom. So we know the row in the table, it's 1. So then our value or critical value is 3.84. So again, to remind you, if our value, the value we calculated, which is 88.65, is bigger than the critical value, in this case 3.84, we reject the null hypothesis, which is what we're going to do, because 88.65 is bigger than 3.84. So we write that up. That also is marks if you're attempting this in an exam or an assignment. So find the critical value in the table, and then the next thing would be decision. So our decision is we're going to reject the null hypothesis because we have a value much bigger than the critical value. So we reject HO. Again, if you're doing this in a college assignment, you would have about 80-90% of the marks. The last thing is the interpretation, saying this in English. So what does this actually mean, right? So that question there, the last part really tests to actually know why you're doing this, right? Rather than to just memorize the steps. So if you really know what you're doing in this case, like in terms of I'm testing whether or not it matters where you were or where you lived on the Titanic, right? In terms of surviving, right? I'm trying to test if that matters at all. So I have to say it in English, right? So the interpretation here, because I'm rejecting the idea that it doesn't matter. So H0 was saying they're independent, so they are not connected. So my interpretation would be something like survival rates depends on passengers' accommodation. So it does matter. I'm rejecting that new hypothesis that I wrote at the start. Thank you for listening.